Today is going to be our last little lecture in the differential equations unit. And it doesn't quite fit in with the rest of what we're doing in this unit, but it is a little bit of an application to integration, a pretty simple and straightforward one. So we're going to start here. We're just going to do two problems. And we're going to start with this problem that says from 1970 to 1980, the rate of potato consumption in a particular country is given by this equation below, capital C of T, in millions of bushels per year. T is the number of years since the beginning of 1970. We want to know how many bushels of potatoes were consumed from the beginning of 72 to the end of 73. And so what we have to be clued in to is that this is a rate function. It tells us the rate at which potatoes are being consumed. And then the question asks how many bushels of potatoes were consumed. So we need to know that to get an amount, we want to integrate rate, which should be easy to remember, right? Integrate rate. Right, so to get an amount, we want to integrate the rate. And so all we've got to do with this is simply integrate capital C of T dt from the beginning of 1972 to the end of 1973. Well, if T equals 0 is the beginning of 1970, T equals 2 will be the beginning of 1972. And then the end of 1973, which would be the same as the beginning of 1974, will be T equals 4. And we could do this by hand to get an exact value, but we might as well use a calculator because the main place you'll see this type of question is a AP test FRQ, and they generally show up in the calculator section. So we're just going to bring up our graphing calculator. And in order to integrate this, we'll go into math and option 9. And we will integrate from 2 to 4, the function 2.2 plus 1.1 to the power of x. And make sure you put your dx in there, hit enter, and you get 7.066032112. And so that is literally all we have to do with this problem. 7.066, and it was 032112. And you are welcome to leave it like that as your final answer, or you can round to 3 or more decimals. Again, on the AP test, you'll never round to less than 3 decimals unless it specifies, and you'll never round until a final answer. So since this is a final answer, we can say 7.066, and don't forget your units because that's often worth a point on the AP test in the FRQs. 7.066 millions of bushels of potatoes. That's all there is to it. And we're likely to see this type of question as a rate FRQ, which is one of the things we're going to talk about at the end of this year. So we'll just do one more quick one, because these are pretty straightforward. And we're going to look at the problem we've got here about an amusement park. So we've got a rate at which people enter an amusement park, which is given by the function E of T. So E of T is this graph here. This is the rate, right? We're at a rate that people enter. And L of T here is 50 times 2 plus T squared e to the negative 0.5 is, well, that's the rate people leave. And we're also going to want to note that it tells us that there are already 4,000 people that are in the park at noon. So we are then, we're going to figure out how many people are actually in the park at 6 p.m. So if we think about this, the number of people that are in the park at 6 p.m. are the number of people that were in the park when we started taking into account the rate they're entering and the rate they leave. That's 4,000 at noon. And we need to add to that the number of people that enter from 0 to 6, t equals 0 to t equals 6, which should be an integral of E of T dt from 0 to 6. And we know it's an integral because to get an amount of people, we need to integrate a rate of the people. And then we'll subtract from that an integral from 0 to 6 of L of t dt. Right? The integral of the rate at which people leave should be the number of people that leave. So in order to find the integral of E of t dt, we've got to look over here at our graph, and we'll want to break this down into 3 segments probably. One right here that's just 600, and it's got a width of 1 and a height of 600. And then these 2 other trapezoids, right? We got a trapezoid here, and we got another trapezoid over here. And the area of a trapezoid is base 1, so in this case that'll be 400 plus base 2, which will be 600, t equals 3, divided by 2, and multiply by the width, 3. That's going to give us 1,500. And then we'll do the other trapezoid, which has base 1 as 600, base 2 as 500, and we'll divide that by 2, and then multiply by the width from 4 to 6 is 2. That gives us 1,100. And if we throw the 600 into that as well, and add that all together, looks like that is 3,200. So we've got 4,000 plus 3,200 minus our integral of L of t from 0 to 6. So we will throw back in our calculator here. We'll choose option or math option 9, which says FNINT down here. You can just hit the 9, or you can scroll down to it. We're going to integrate from 0 to 6. 6 there. Zero to 6, and our function was 50 times, and it was 2 plus t squared, so we'll just use x, 2 plus x squared, and then it was e to the negative x over 5. And be careful with the negative sign. A lot of people put a minus sign there. If you put a minus sign instead of a negative sign, you're going to end up with an error, and you don't want that. So we've got 50 times 2 plus x squared e to the negative x over 5 dx integrated from 0 to 6. And it looks like that gives us 2106.411265. So we'll go right back over here, and we'll now just subtract 2106.411265. Probably write the numbers in the right order. And if we go in and we just calculate what all that comes out to be, 4,000 plus 3,200 is 7,200. And if you subtract from that 2106.411265, we're going to end up with 5,093.588,735. And we don't want to leave our answer like that because it specifies in this particular problem. Actually, it doesn't specify because how many people are in the park. I'm going to say let's round to the nearest person. So round that to the nearest person. We're going to say 5,094 people. And that's basically the end of this unit with just the information we need to know. We're going to spend some time in class in the next week or so talking about 3 different specific types of free response questions. So we're going to do rate FRQs, which involve stuff like this, integrating the rate, among other things from previous units. We're going to do some specific motion free response questions, kind of like the stuff we did at the beginning of this unit. And then we're going to look at some that deal with slope fields and separable differential equations. And then that'll be it for this unit, and there's only one more topic to go for the rest of the school year. So that is it for this unit, other than the free response questions.